Okay, so you might know that when you are writing a modern tech document using LaTeX, you are basically interfacing with a massive collection of macros that are built on top of a foundation of three things, right? So the first, of course, is the original TeX82 engine, or modern variants thereof, the kind of thing that I've been talking a lot about in the last few videos. But you also need to have the so-called e-TeX extensions, or maybe it's pronounced epsilon tech extensions, I'm not sure. And these are kind of a collection of new tech primitives that were introduced, and also along with some changes to some of the potential data structures that introduced a lot of, I think, really important both quality of life in terms of debugging, but also just kind of utility facilities that let working with a macro expansion language like TeX even possible. Things like being able to, let's say, manipulate strings in memory rather than just always reading and writing to files, or there were also improvements like being able to typeset TeX right to left instead of left to right, or things like this. Okay, so you need TeX82 and you need the e-TeX extensions, and you also need for the modern L3 kernel a small number, I don't know, small 20-ish number of additional kind of utility primitives. And one of the things that I was really quite excited about is that as of just a few days ago, the kind of hobby engine that I've been working on now finally passes not just the original trip test, the thing that made TeX82 TeX82, but also the e-TeX extensions version of this, which means that I am, in my mind, breathtakingly close, although with a lot of work left to do, to being able to use this hobby project to actually typeset, modern LaTeX documents. So given that, I thought maybe this would be a good time to step back and talk a little bit about almost a philosophy of testing. TeX is famously one of the most bug-free, complex pieces of software that's been written, and I've been trying to think seriously about what maybe we can learn about how should we write tests for our code based on, well, whatever the testing philosophy of TeX happened to be. So the first thing that I want to do is maybe show, maybe I'll show actually the manual to the trip test. So if I go to test, trip test, and then tripman.tex. So we'll read it in the kind of original TeX format rather than compiled as a PDF. And basically what this is a manual that describes how should you test your TeX engine. And there's like an interesting kind of discussion of the philosophy of, how should you think about understanding whether your program is actually debugged or not. Is it valid? Is it doing the right thing? A lot of time, as I think we all know, we often end up testing the happy path and not the harder half, let's say. The fact that he thinks it's half is kind of very funny to me. And so this document describes Knuth's version of how should you test the TeX engine. And one of the things that I want to highlight here is this kind of, I think, somewhat delightful version of a definition of you are allowed to claim that your engine is TeX under two conditions, the second of which is passing this test that we're about to describe. And that's kind of a very interesting, the thing which is TeX is something which has the behaviors of TeX in this very carefully detailed way. I also really want to highlight this item 1 because I think it's like delightful and human, and you also, whoever wrote it must be happy with the way that it works. And I think this is like a really delightful aspect of when are you allowed to call something TeX or something. So then what is this document? It's basically just a bunch of appendices that explain in detail how to carry out this test and then what the expected outputs are. Because the way that you carry out this test is basically to try to compile a specific TeX file a few times in a few different ways after having prepared your engine in a certain way. And it then describes in great detail, okay, this is what should have appeared on the terminal the first time you ran it, or here's what the content of the log file should be after you run it the first and the second time, or here's what the final output DVI file should be after running this. And then there is just an explicit list of, here are the handful of allowed deviations from what the kind of golden master snapshot of these different files happens to be, right? So the dates and maybe the file names will be a little different. There is a few very carefully detailed set of cases where floating point math is allowed to work differently. Again, it kind of blows my mind, but a lot of TeX was developed before the IEEE standardization of floating point math. And so Knuth, wanted to avoid it as much as possible and described very specific cases where the few times floating point operations were actually used, here is exactly the extent to which they're allowed to be different, right? And then a few other things, there's some system-dependent rounding of kerns in for accent things. There's potentials that the way help messages would be displayed or total memory allocations might be different. Again, probably because, some computers at the time didn't even have 8-bit, bytes, and so who knew what a memory word was, and so memory usage could probably be different, right? So, okay, great. So this is like the style of testing. And then what on earth was this, what is this, trip.tex file? It was it was madness, right? So this is a diabolical test file, watch your step, thank you, Knuth, in which, rather than trying to write the happy path, Knuth tried to write the least happy path imaginable in a file which I think is extraordinarily difficult to read. So one of the things that's interesting here, I think, is that it is hard to understand what the test is actually doing. I mean, if you really dig in and you really know what the engine is, you can, of course, piece together exactly what's happening at every step, and that would be its own very long explainer video to kind of, I think it might be interesting, but to kind of walk through exactly what is happening in all of these, trying to apply or assign additional parameters to a font which is not supposed to exist, or, doing all kinds of defining things to abort every paragraph abruptly, or doing things that you would never want to do when actually typesetting a document, but which in combination, very carefully, it turns out, goes through almost every corner and edge case in the engine, right? And reading this is just, it kind of bends my mind every time, and the few times that I've kind of broken trip test compliance, trying to go back through this and understand what was supposed to be happening and what was my engine doing differently was the hardest part of this whole process, right? But the other thing that I want you to notice is that actually it's not very long. It's only about 450 total lines of a tech document that you compile a few times, you run through the engine a few times in a few different ways, and that's the whole test suite in some sense. And so let's take a quick look at maybe how I thought about setting this up and kind of setting up the testing framework around this. I am not really, I think, an expert in CMake. I just I use it for some of the kind of scientific software that I write, so I've learned a little bit, but there's a lot that I really don't understand. But basically, I try to set things up with a bunch of helper functions, a bunch of kind of additional scaffolding, because a lot of the tests come in this flavor that you're basically comparing this file to that file, and so let's try to understand what might be going on there. And in particular, for the trip test, what you're doing is basically running the executable, running your engine with a specific input the first time, and then running it using a format file that the first run generates, running it again and kind of looking at, the terminal output and the log and the DVI, subject to, let me actually go ahead and do this, subject to some deviations that Knuth specified as allowed deviations. So if I go back to the tripman for a second, there were these like itemized, here are the things that are allowed to be different. And so what I tried to do was just, I don't want to actually look at files every time. I tried to just go ahead and say, let me kind of try to codify, okay, here is a way of taking the output files and then just doing, regex replacements or, scanning for specific differences and saying, oh, I was told that I was allowed to have a number and length of strings differently, or same thing with memory statistics or stack sizes, and so let me put in some regexes that kind of handle the things that are allowed to be different for me, hopefully without touching anything that is not allowed to be different. And, I think there's some places where the tripman leaves open to interpretation exactly where the boundary between passing and not passing should be, and so I've tried to make it pretty transparent. Well, here was my interpretation, and maybe here are a few cases where you should be a little bit suspicious, because, for instance, I have tried to generalize my engine to allow eventually Unicode input, so there are some error messages that I'm just unconditionally not throwing. And what e-TeX did is gate similar issues behind an additional input character, and I just have chosen not to gate that. And so maybe that means that my engine doesn't pass the trip test, but in this very specific way, basically. Okay, so that's kind of how I thought about scaffolding the testing framework for this project, making it so that it would be easy. Every time I compile the code, I can just run all the tests, check if anything regressed, and and do that. And really setting up that kind of scaffolding was, I think, the only thing that let me make any real progress on this project. Because otherwise, being able to rearrange the memory array in such a way that it's fundamentally different from how Tech82 did it, or rearrange and have this page intermediate representation so that you can ship out to DVI or PDF or HTML. I wouldn't have been able to do any of that, I think, correctly if I didn't have this constant, easy, fast to run set of tests that were just like, well, you've made a change, and you've made a change which definitely breaks what the tech engine is supposed to be, right? So that's nice. One of the things that I wanted to show, is I mentioned that the trip.tex file was only like 450 lines, and the total size of this code base is something that's like 40,000 lines of code. Now a lot of that is different from what Knuth wrote. Maybe something like between 20,000 and 30,000 lines of code would be closer to the like C-Web implementation. I should probably actually go double check that sometime. But so, that's tens of thousands of lines of code. Our whole test suite is like running a 450 line file a handful of times, one of the things that I thought was kind of interesting to think about was, well, did that really test all of the edge and corner cases, and what's the like code coverage of this thing? And code coverage is obviously not the be-all end-all of testing, but I think it's at least some useful metric for, well, it's a useful metric for something. So I kind of saved this so that I don't have to remember. I don't know why. Typing CMake build type is just my least favorite thing, and so, now I can just copy and paste it. So basically what I've done is I added a CMake target that will basically compile in the unoptimized version of the binary. It will, build the project, and then this make coverage target basically just runs the test suite and then generates all of the code coverage stuff. And then I set it up so that it would automatically open up Firefox over here with this kind of fun code coverage report. So let's make that bigger. And the top line number here is like, I don't know, like almost 80%, 77%. That's like kind of impressive to me already, just with this 450 line triptych file. But it turns out that really almost everything that it's not testing it falls into one of three categories. Category one is stuff that I wrote, so all of the stuff to do with tagging and accessible PDFs. Of course, the trip tests don't do that. Stuff to do with HTML and PDF output. Of course, the trip tests don't focus on those code paths at all. So stuff that I wrote. Stuff to do not only with the PDF, but actually the DVI output is one of the notorious places, I think, where the trip test is not completely exhaustive in testing all of the code paths of DVI generation that Knuth wrote. And so there's definitely been a few times where I changed something and it passed the trip test, but the DVI output of files different than the trip.tex output changed a little bit. So I have to think about adding some more tests there. So that's two categories. And then the other category is diagnostics, right? All of the kind of fatal error pathways are not tested in the trip testing. And so that's like one category that's like a whole category of code paths that Knuth said, I'm not going to explicitly test the unrecoverable failure modes. And to be honest, if that wasn't the case, I might not have been able to make some of the changes that I ended up making. So I thought that was kind of like an interesting, glimpse into how, one can write admittedly a completely inscrutable, but relatively short test file that nevertheless, look at this, it's covering 90%, 97% of macro expansion pathways, 93% of things to do with the basic scanning of files and token lists. And, the core parts of the engine are really extremely thoroughly tested by this crazy, crazy setup. And I don't know, it's something that I wanted to kind of think about and meditate on a little bit with respect to my own practice. I really think that, well, especially with LLMs, right, the total volume of code that we can generate is just astronomical in comparison to what it used to be. And so I think it's really important to think a lot more seriously about how do we kind of systematically think about how should we be debugging and testing our code and verifying correctness and things like this. And I don't know, like there's a whole continuum of possible approaches. The trip test is in some ways like a golden snapshot style of test, or maybe I want to think of it as like a handwritten fuzzing test or something, I'm not quite sure. But there's a whole continuum, right? And I'm often used to thinking about the kind of unit testing side of things. And I've always struggled with the fact that I think it's really hard to write non-trivial unit tests that are nevertheless independent of the detailed implementations, right? I often find I write unit tests and that's nice, but if they're interesting, then if I change the code, I have to change the tests in a way which is not as nice, right? And so then I also really like behavioral style tests, maybe not behavioral driven development, but I like the idea of describing, given this scenario, here is the expected output that I think will happen, right? And in some ways, that's kind of in the flavor of the trip test. Given this crazy file, here is the complete specification of the output. But I often find that when I'm writing behavioral style tests, I do not really interrogate the internal state or like the boundary between subsystems or something like this. And so I think a lot of times it's hard for me to use behavioral style tests to really poke at the unhappy path of the code that I'm writing. And I recognize that both of these things, both of my issues with unit testing and behavioral testing are probably like skill issues on my part, and I need to learn how to use these tools more effectively. But I don't know, like I think there's maybe something to be learned about this style of, extremely detailed, unhappy path version of golden snapshot testing that maybe I should, think more seriously about and embed into my own software engineering practice when I'm writing, scientific code bases or something. And I don't know, this isn't something where I don't have any actual like answer or messages here. I would love to hear your feedback on, I don't know, like what have you found actually works well when it comes to testing in non-trivial ways and in ways that let you, one of the things that I think is remarkable about this trip test is that not only is it so detailed and fiendish and testing all these different possible code paths, but it also has enough freedom in there to really substantially change the implementation without breaking the tests at all, right? I was able to completely rewrite what the underlying memory representation was. I was able to add intermediate representations of pages to, ship to DVI or PDF or HTML in a way that, Tech82 never imagined. I've been able to start disentangling some of these subsystems, and, despite being able, despite having this ridiculous set of tests, it still gives the freedom to, again, like make these substantial changes. And so, I don't know, I think there's still a lot for me to learn from Tech82 and this kind of interesting style testing. And again, I'd love to kind of hear your feedback on that. Okay, so kind of an odd place to end, but there we go. Until next